In our first example, we want to use this general term formula to do a few things. We have a sequence 8, 4, 2, 1, and zero point 0.5, and we want to show that the sequence is geometric. We want to find the general term u sub n. This is like finding the equation. And then we want to use that equation to find the 12th term and represent it as a fraction. So let's jump into this. So we want to first show that the sequence is geometric. Well, we have to kind of remember what the definition of a geometric sequence is. It is geometric if and only if u sub 1 over n, u sub n plus 1 over u sub n is equal to some common ratio. And the reason why we use these n's here is because this doesn't only apply to u sub 2 over u sub 1 or u sub 9 over u sub 8, but this means that any two consecutive terms have a common ratio. So it's almost best to pick almost these terms at random and then prove that they have a common ratio. But for this example, I'm just going to pick the first few terms. So I'll take 8 and 4, and I want to find that 4 over 8 is equal to some number, and that's equal to 1/2. That's u sub 2 over u sub 1. I can take another pair of terms, and I could take 4 and 2, and that would be u sub 3 over u sub 1. And that would be equal to 2 over 4, which is equal to 1/2. So far, so good. Let's take one more pair of terms here, and we'll compare. Let's do 1 and 0.5. So this is 1, 2, 3, 4, 5. So this is u sub 5 over u sub 4. That's equal to 0.5 over 1, which is also equal to 0.5, which is also equal to 1/2. So this has a common ratio. And so it must be geometric. So we would say that u sub 1 is equal to 8. So it has an initial term, and the common ratio is equal to 1/2. So if it has these two things, then we're talking about a geometric sequence. So since I've shown these two things exist, then therefore it is geometric. Part B, we want to find the general term u sub n. So remember that formula we had from before, u sub n is equal to whatever u sub 1 is times r to the n minus 1 power. So the things that I need to find are u sub n, or u sub 1 and r, and I did that in the last example. So the general formula will be u sub n equals 8 times 1/2 to the n minus 1 power. This is my initial term of 8, and this is my common ratio of 1/2. All right, that was easy. Now let's use that formula, and we're going to find the 12th term as a fraction. So I'm going to rewrite that formula again. U sub n equals u sub 1 times 1/2 to the 12 minus 1 power. All right, so let's dive into this. Actually, let me get rid of that u sub 1. That should be an 8. So the first thing I do is I need to follow PEMDAS here, and I need to simplify this exponent, and I need to make this exponent of 11. So u sub 12, looking back here, I should have actually made this a u sub 12, not a u sub n, since this is the actual 12th term that I'm looking for. So let me actually fix that before moving forward. All right, so now we're back to u sub 12, and this is going to be equal to 8 times 1/2 to the 11th power. And taking that a step further, I'm going to take 1/2 to the 11th power, and that is equal to 8 times 1 over 2 to the 11th power, and 2 to the 11th power is equal to, let's see, I don't have that one written down. So 2 to the 7th I know is 128. Let's see, let's just count a little bit. 2 to the 8th, to the 9th, to the 10th, to the 11th. So this is going to be equal to 256, 512, 10, 24, and 2048. So 2 to the 11th is 2048, so 2048. All right, now we multiply that together. U sub 12 is equal to 8 over 2048. And that is going to be equal to u sub 12. That one I do have written down. That's 1 over 256. Actually, now that I'm looking at it, this looks like it's kind of an intimidating calculation to make, or really big numbers. And I could have actually made this a little bit simpler rather than take this out to 2 to the 11th. So let's just kind of sidebar this for a second and show you maybe a better way that I'm seeing that I could have approached this. Once I have this 8 times 1/2 to the 11th power, I could have said that's equal to 8 over 2 to the 11th. Well, I know that 8 is also equal to 2 to the 3rd, so this is 2 to the 3rd over 2 to the 11th. and I can use my exponent property to say this is equal to 1 over 2 to the 8th. And now, yes, I'm still having to calculate 2 to the 8th, but I could have stopped my calculations here rather than go all the way to here. This is also equal to 1 over 256. So sometimes this would be one of those situations where it's best maybe to not actually multiply and expand stuff and see if we can't simplify anything first. So a different way to calculate this. No one way is necessarily right or better, but consider that for your own understanding. All right, so why don't you try a problem that's very similar as the last one. We've got a new sequence, and you have to do these 3 things. So pause the video, give this one a shot, and we'll see how you did. All right, so this thing is geometric. We have an initial term of 5 and a common ratio of 2. Here's my general equation, and then here's what u sub 15 is equal to, 81,920.